GATE 2015 Civil Engineering Set 2 Question 32. A steel strip of length 200 mm is fixed at ends A and rests at B on a vertical spring of stiffness K equals 2 Newton per mm. The steel strip is 5 mm wide and 10 mm thick. A vertical load P of 50 Newton is applied at B as shown in the figure. Considering E of 200 gigapascal, the force developed in the spring needs to be found in newtons. The relevant NPTEL reference has been listed. So as seen in this figure, the load P is acting on the end B and it is also supported by a spring. So the spring here acts as a prop. So this beam would be converted to a propped cantilever. Let us assume the reaction in the spring as R. So the net load that will act on the end B is P minus R. So due to this load, the deflection that would happen is P minus R into L cube by 3 EI. But this deflection would also be equal to the load in the spring divided by the spring stiffness. From this equation, we would get P minus R by R equals 3 EI divided by KL cube. From this, we get P by R minus 1 equals 3 EI by KL cube, which would give us P by R as 3 EI plus KL cube divided by KL cube. So using this equation, the reaction in the spring can be found when P and other parameters of the beam are known. Here E is the modulus of elasticity of the beam, L is the length of beam, I is the moment of inertia of the beam. So as we saw in the previous slide, P minus R into L cube by 3 EI, that is the deflection at the end B, will be equal to the load in the spring by K. From this we get P minus R by R equal to 3 EI by K L cube. In this case, E has been given as 200 gigapascal. This would be equal to 2 into 10 to the power 5 megapascal. We will consider megapascal since we need to find the answer in millimeters. It is also given that the width of the steel strip is 5 mm and the depth is 10 millimeter. The length of the strip has been mentioned as 200 millimeters. The spring constant is mentioned as 2 Newton per mm. So using this, we will have P minus R by R equals 3 into 2 into 10 to the power 5 into inertia, that for a rectangle would be BD cube by 12. This will be divided by K, that is 2, and L cube, that will be 200 cube. This would give us P minus R by R equals 15.625. From this we will get the value of P by R as 16.625 and R would be P by 16.625. It is given in the problem statement that P is a force of 50 Newton. So substituting the value 50 by 16.625 would give us R value as 3 Newton. So the force developed in the spring is 3 newtons. The relevant NPTEL reference has been listed.